Hello and welcome to chapter 3 of trigonometry. So in trigonometry, we're going to basically connect the unit circle from the degrees that we learned in chapter 2, and now we're going to convert it in terms of radians. So if we think about radians, okay, radians basically is an angle in terms of pi. So an angle measure with pi. So we're now incorporating the fact that it's a circle, and we're converting it to a different unit. So if we make one full rotation, okay, we know that that's usually 360 degrees, but in radians, it's actually going to be considered 2 pi. Okay, so whenever you see a full rotation that used to be 360 degrees is now 2 pi. Okay, so if our 360 equals 2 pi, then our 180 is going to be pi, right? If it's halfway around, half of 2 pi is just pi. Okay, so that's a really big piece to understand, right? If you know that what represents a full rotation versus a half rotation, you can kind of get your bearings on where you are in the coordinate plane. Okay, so if we solve these equations, we can understand that if we solve for 1, it's equal to pi over 180 or 180 over pi. Okay, so this is going to come in handy when we start converting between degrees and radians, or radians back to degrees to solve our unit circle. So first we're going to talk about degrees to radians and then radians to degrees. Okay, these equations look similar. The whole idea is that you're either trying to give your measurement pi to change into radians, or you're trying to take it away. So if we're trying to go into radians, we're going to take our degrees measurement and we're going to multiply it by pi over 180. The reason we're doing that is, again, we're trying to make sure pi is in this angle measurement. But when we go into back from radians to degrees, we're trying to take it away because we've never seen a degree measurement with pi as part of the angle, so we're trying to take that away. So when we go back into degrees, we're going to take our radians measurement and we're going to multiply it by 180 over pi. Okay, radians will have pi, so by making the denominator pi, they're going to cancel out, and then now we're back in degrees. Okay, so sorry. Now let's do an example of this. Okay, so let's think about, like, what if we were converting 60 degrees into radians. Okay, so we're going to take our 60 degrees and we're going to multiply it by pi over 180. Okay, remember when you multiply fractions, we're just going to multiply across, so 60 times pi, which would just be 60 pi. And then 1 times 180 would be 180. Okay, and we can always try to simplify this. We want to basically ignore the pi so that we make sure that stays in our final angle. So if we take 60 over 180 and we try to simplify that fraction, we could divide out a 60, which would be 1/3. So this would be pi over 3. Okay, so whenever we see a 60-degree angle, in radians, that is actually pi over 3. So if we think about connecting that back to the unit circle, okay, so I'll just draw a nice little coordinate plane. Okay, and if we're thinking about just increments of 30 to create this 30 or the 60-degree angle, we can basically separate each quadrant into thirds. Okay, I'm only going to do the upper half, and then we'll kind of get the same idea on the bottom. Okay, obviously they're not perfect, but you get the idea. This is the positive y values are separated into 6 equal pieces. So in our degrees, we're thinking about this as 30, 60, 90, 120, 150, and then of course 180 on the x-axis. Okay, so we already know that pi over 6 is actually equal to pi over 3. Okay, since this is broken up into 6 pieces, we know that, I forgot to put 0 over there, our 180 is always equal to pi. So if we think about this in 6 increments in order to get to 1 whole of pi, 30 is going to be pi over 6. The reason 60 is pi over 3 is because it's just simplified 2 pi over 6, right? Because it's these 2 pieces of the upper half of our coordinate plane. All right, once we get to 90, this would be our third piece, so 3 pi over 6, which is really pi over 2. 120 would be 4 pi over 6, which would simplify to 2 pi over 3. 150 would be 5 pi over 6. And then at pi, we would have 6 pi over 6, which would simplify to pi. And if we keep going, we could add more legs here and we could keep going. But just for now, let's keep it at the upper half, okay, just so we can kind of get an idea that when we're thinking in our degrees, the 30, 60, 90, 120, 150, 180 is really just 6 equal pieces of the coordinate plane that we already know. All right, so let's go back and let's do an example of converting from radians back to degrees. So let's say pi over 4. All right, so when we're going from radians to degrees, we want to make sure we take pi away. So in order to do that, we want to put our pi on the bottom. When we multiply across, we get 180 pi over 4 pi. Okay, remember if something's on the top and on the bottom that we can factor out, it cancels. So pi over pi cancels. And then where is my pen? We can simplify 180 over 4 is equal to 45 degrees. So whenever we think of a 45-degree angle, it's in increments of pi over 4. Okay, so let's think about that. We've talked about our 30s, 30, 60, 90, the increments of 30, but we haven't talked about the middle ones on each. We haven't talked about the 45s. I want to pivot here and make just a side comment. As you're starting to connect between your radians and your degrees and all that stuff, I know it might be easier to look at the unit circle right now in terms of degrees, and that's okay. Okay, if you can't think of the radians measurement right away, that's all right, because you can always convert back and forth. Now that you know how to convert, you can relate them back and forth as you need to. Okay, so now let's look at our coordinate plane, but now let's take it into 45-degree angle measurements. So this time, 45 degrees is going to split our first quadrant nicely. It's going to be our 90 degrees, and then it's going to split our second quadrant nicely. So these are going to be 0, 45, 90, 135, and 180. Okay, so we've basically broken up the upper level, or the upper half of our coordinate plane into 4 equal parts. Okay, so we just found that 45 is going to be pi over 4. Since this is going to be 4 quadrants, we can think of 90 as 2 pi over 4, which still simplifies to pi over 2. This would be 3 pi over 4, which does not simplify for us. And then 180 would be a full 4 pi over 4, which we already know is going to be pi. Okay, so that's just kind of the gist. We're basically going to take these two, because we already know we've seen this in degree measurements, but we're going to take these and kind of merge them together and just think about all of our measurements now in degrees instead of, or I'm sorry, in radians instead of degrees, okay? So if we put this all together, we have a nice little chart down here. Oh, I forgot to mention this. So sometimes if it asks us to multiply or approximate, okay, just make sure you're reading the directions. This would say to the nearest degree. So about 1 radian is about 57 degrees. Okay, so now let's go down to our unit circle. So this is our completed unit circle without the x and the y coordinates. Okay, so all of these are basically the same thing, right? You've already seen the 30, 45, 60, 90, 120, all that stuff. So remember, we were just talking about that are 30, 60, 120, 150, 210, not 225, 240. All of these kind of go together, okay? Which, if you see, so do their measurements. They're all basically either have a denominator of 6 or a simplified fraction from a denominator of 6. Okay, for example, okay, your pi over 6, this was really 2 pi over 6. This one was 4 pi over 6, 5 pi over 6, 7 over 6. This one is 8 pi over 6, 10 pi over 6, 11 pi over 6, and then this is always 12 pi over 6, which simplifies to 2 pi. Okay, the middle ones, let me see if you can see. Let's not do green. Let's just do blue. So the 45s here all go together. Notice they're all either simplified, not that one. They're either simplified increments of fourths. Okay, so if we think about those, let's just do those in blue. So you have your pi over 4, your pi over 2 up here, I forgot to write, would be 3 pi over 6. This one would be 6 pi over 6, 9 pi over 6. So then when we think about it in terms of 45, this is 2 pi over 4, you got your 3 pi over 4, this is 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi, and then this would be your 8 pi over 4. Okay, so if you're able to simplify your fraction, feel free to. You always can. The other thing is if your angle is not between 0 and 360, or 0 and 2 pi, you can always, remember, find the coterminal angle. So let's say your angle is 7 pi. You can continue to subtract by 2 pi until you get into the measurements of 0 and 2 pi. And then you can use it in reference to this unit circle. Okay? So just to recap, okay, pi is equal to 180 degrees. If we're going to go from radians to degrees, 180 over pi, degrees to radians multiplied by pi over 180.